All these snow days are killing me that we have to make up our class time like this, but we'll make it work best we can. This morning, we're going to take a look at this idea of odd and even functions. And what we're going to be doing is we are going to be taking a look at our function, f of x, however that's given to us, and we are going to evaluate this for x of negative x. Now, we already practiced this up a little bit earlier in the course. What we're going to do now is take a look at, after we do this substitution of negative x, what does our function look like? What do we have left? And then, based on how that looks, it's going to tell us if this function is odd, even, or neither. So when we take negative x and substitute it into our function, if what we have after we do the algebra, it looks exactly like the function that we started with, this is what we are going to know as an even function. Whoops, off the screen there, even. So when it looks exactly the same, it's even. When we take our f of negative x, so we put negative x in and we do the algebra, if what we have left looks like this, the opposite of our original function, then we have what we know as an odd function. And by the opposite, what I mean by that is every term in our function is going to have its sign swapped. So odd, even, and then the third possibility is after we evaluate f of negative x, if some of our signs, for some of the terms the signs change, but in other terms the signs are the same as they were originally, then that's going to be known as a neither, the mixed bag. So let's take a look then at a couple of examples. If you can't see these, I'm not seeing them well on my screen, you have the paper in front of you. And the process we're going to use in these examples is to substitute in our f of negative x, substitute our negative x in. So in this first example, we have f of x is equal to x squared plus 6. So putting in negative x, we have negative x squared plus 6. Notice parentheses. Parentheses, I can't stress enough, use them because you want to make sure you evaluate these terms correctly, and having that information in parentheses will help you keep the information correct. Negative x squared, negative x times negative x is x squared plus 6. When we look at this versus our original function, it's the same. So stating that like this, f of x is equal, f of negative x is equal to f of x. It's the same. This would be an even function. We have another example. G of x is equal to 7 x cubed minus x. Again, we substitute in negative x, 7 negative x cubed minus this subtraction sign from our function, and then we have another negative sign because we're substituting in negative x. Evaluating it, negative x to the power of 3 is negative x cubed. So I'm going to pull that negative sign out in front of the 7, and we have negative 7x cubed, negative, negative. This becomes positive x. When we look at this, as compares with our original function, we had a positive 7, now we have negative. We had a negative x, now we have positive x. All the signs have flipped. So this would be an odd function. I'm going to show you another way that you could consider this, if it helps. Let's factor out a negative 1, so to speak. So if I pull out my negative sign in front, what we have left is 7x cubed minus x. When I write it in this form, I can see that g of negative x is indeed negative g of x. Either way, you can recognize that it's odd either way. I just show you this as another way that you can think about it if you find that helpful. And then for this last example, we have h of x is equal to x to the 5 plus 1. Always substitute in negative x to the 5 plus 1. Negative x to the 5th is x to the 5th, and then it's negative plus 1. In this instance, we can see we had positive, this flipped to negative, this was positive, and it stayed positive. So this is an example of the mixed, what I refer to as the mixed bag, where some of the terms did change their signs, others stayed the same. So this function would be in the category of neither odd nor even.